Hello guys, welcome back to my YouTube channel. My name is Simba. I'm going to take you through the carbonyl-alpha-substitution chemistry, focusing on the alpha hydrogens. Okay, carbonyl-alpha-substitution, focusing on the alpha hydrogens. So I'm going to show you with the aid of two questions on how you can identify the alpha hydrogens and how you can tell which alpha hydrogen is more acidic to participate in an alpha substitution reaction. So I have two questions that I'm just going to show you. So this is the question where you have to identify the acidic hydrogens with a pKa value less than 25. So the first question, this is the molecule that we have. And the second question, the second molecule, is this is the molecule. So we have to figure out the alpha hydrogens. So to begin with, I'm just gonna try to emphasize the idea of the pKa value and also the Ka value, which is the acid dissociation constant. So normally for strong acids have a high Ka value, which is the acid dissociation constant, and at the same time they have a low pKa value. So this is what you have to bear in mind in order to understand which alpha hydrogen is regarded as the strong acid. So if you check in this structure, we do have two alpha carbons here, right? And as I indicate, this alpha carbon and this alpha carbon. So I want you to take note that they are called alpha carbons because they are carbons that are attached directly to the carbonyl group. This is the carbonyl group. Okay. So what happens, this carbonyl group, it has what is called a negative inductive effect, meaning to say it can pull away electrons from this carbon. It pulls electrons. Then also it can pull electrons from this carbon. Okay, so leaving these alpha carbons with a partial positive charge. And that partial positive charge is the one that is responsible for making these hydrogens acidic. Okay, by acidic hydrogen, we mean that they are hydrogens that are easily replaceable in the presence of a strong base, like maybe sodium hydroxide or, and so forth. So we want to figure out now which ones between these two sets of acidic hydrogens can act as a strong acid. So if you check for this hydrogen, this carbon is attached to this methyl group and it is also attached to this ethyl group. Okay, so what's happening to this carbon, even though it does have a partial positive charge due to this carbonyl group, that partial positive charge is being neutralized by this ethyl group and also this methyl group. Okay, because these two groups, they have what is called a positive inductive effect, because electrons, they can be donated towards this carbon to neutralize that partial positive charge. So that effect, it nullifies the effect of that positive charge created here to this hydrogen. So this hydrogen is not really easily replaced by any base. Okay, so it makes this hydrogen a weak acid because it's not easily replaced. So it becomes a weak hydrogen. Unlike for these hydrogens, they are only attached to this carbon, which feels that negative inductive effect of this carbonyl group. So these hydrogens, they are experiencing a direct effect of that partial positive charge here. The partial positive charge created on this carbon due to this carbonyl group. So these hydrogens, they are exposed to that partial positive charge. So electrons, they are withdrawn away from these hydrogens, weakening the bond between the carbon and the hydrogen, so making these hydrogens easily replaced. So therefore, the easier with which to replace a hydrogen, the more stronger it is as an acid. So this makes these hydrogens more acidic. So I hope this is clear. So moving on to the next question, this one. Okay, if you check, you have two sets also of alpha carbons. So there's this one alpha carbon, I named it A. Then we have these two alpha carbons, I named them B, because these two, they are equivalent carbons, right? So what is happening here is that these two carbons, they are experiencing a similar effect, but which is that effect is very weak compared to this carbon, because this carbon is experiencing a double impact due to these carbonyl groups. So this alpha carbon here, there's a strong partial positive charge created here, okay, which makes these hydrogens more acidic, because the electrons on this bond, the CH bond, they are drawn toward this carbon, leaving this hydrogen more exposed and easily replaceable. So these two hydrogens, they are more acidic compared to the other hydrogens. So based on that question requiring acidic hydrogens with a pKa value of less than 25, I would go for these two hydrogens in this case. Yes, I'm not saying these two hydrogens, also these sets of hydrogens, they are not acidic. They are acidic hydrogens, but they are weak acids. So I hope this is clear, and I hope it makes sense to you. So if there's any question, or if there's any clarity, or if there's any suggestion, or drop a comment, then yeah, I'll take it from there. So I hope you enjoyed the video, and stay tuned on my channel. I'm going to be posting more videos. This is bye for me.